Hi everyone, welcome to this session. So in this session we will be solving this question through the graphical method. Okay, it is a very interesting question, a little difficult obviously for many reasons because there are so many ideas that you will be using. But let me say this, the only thing that you need to appreciate for these type of questions is that yes, they are difficult of course, but the fact that they're difficult is not only because there are so many concepts, but they're difficult because sometimes even the calculations are a tad bit messy. First thing first, let's appreciate the critical points of the graphs. Once you understand this thing, the magic or the beauty of this method is that once you really start appreciating the method, you will not be needing any coordinate axis. You'll not be needing anything like the blue lines or the green lines. You can just do it very simply. Okay, so let's try and understand how we can solve this one. The first thing first, tell me what are the critical points of this graph or this equation rather. So the critical points obviously are going to be on the x-axis the points x equals to 1, 2.5 and 5. Okay, around these points the slope of the graph will change, if at all it changes. The only thing that you need to appreciate is that the entire graph, the x-axis, due to these three critical points have been divided into 4 junctions. Okay, these 4 junctions, very interesting junctions, and we need to understand how the graph is behaving in and around this junction, or in typical textbookish language you can also say how the graph is functioning in the near vicinities of the critical point. So first of all, let's try and understand what are the slopes around these junctions. Okay, so let's start off with the first one. So to calculate the slopes, what I can do is, and this is a little tedious process, we will have to take a point which is beyond this 5, and this 5 will correspond to this term 4x minus 20. Take any point, you can actually take a point 6 also and then substitute, but then just appreciate that any point beyond this 5 towards the RHS of 5 will always be positive for this one. In other words, the modulus is going to be positive, or the variable that is inside the modulus sign will be positive, and obviously the other two is also going to be positive. What does that mean is that for this particular point x, okay, which is towards the RHS of this critical point 5, I can very simply write this as minus 4x, minus 2x. I'm adding these, okay, I'm adding with the negative sign, so that is what I'm doing, minus, and then there is a x. This is minus 6x and x, that is minus 5x, okay. In other words, m is equals to minus 5 for the first coordinate. You can do this a little quickly also, okay, you don't really need to sit and do minus 4 and all that. Obviously you will improve as in time progresses. The next thing you will appreciate is that take a point towards the LHS of the critical point 5 and you will realize that now suddenly the variable x for this term is not positive, it is negative, because it is towards we are considering 5 to be the origin now. Okay, so think of it as in the x-axis 0 ke right hand side mein positive 1 hota hai, LHS mein negative 1 hota hai. So that's the thing that we are using. Now this is negative, so this part is going to be negative, the other two part is going to be positive. So negative 4x, there is a minus already there, so this is going to be 4x. Okay, the other term is going to be minus 2x and x. So 4x minus 2x is 2x plus x, that gives me 3x. I don't really care about the x. Okay, the x is nothing, the 3 is what I need, and 3 is the slope. So again I'll write m is equal to 3. This is important. At this point I will hold. Okay, now I have given you the idea how to calculate. I would expect you to be a little quick in order to calculate the values. Now m equals to minus 5 is for this one, m equals to 3 is for this one. What about this one? Let's try to do this without putting pen on paper. So this is negative, this is negative. Okay, beyond 5 and beyond 2.5 towards the LHS, both of them are negative. So 4x plus 2x, 6x, and towards the RHS of the critical point 1. So this is going to be 4 plus 2 plus 1, that is the slope is 7. This m equals to 7, if you understand, now this is a very steep slope. If I have to explain you, so this is typically m equals to 1. So the line m equals to 1 is a slope something like this. A line which is m equals to 2 may be considered to be like this. This is called a steeper line. What exactly does steeper means? That it is actually going to, so suppose this is the near vertical, so this will go towards the vertical. Okay, the affinity of going towards the vertical increases as we start increasing the value of the slope. What happens if the slope, again I'm digressing a little bit, but then please understand this. What happens if the slope is a fractional value? Suppose m equals to half. In that case, the line will be flatter in the sense that it will start having an affinity towards the x-axis. Okay, and the same thing happens for the negative slopes also. I don't think I really need to explain this, but then a negative slope will, this is also a negative slope, but for our purposes we are taking the line which is from the origin. So this is the idea of a negative slope. So m equals to minus 1, and the same idea holds true. So the one which is let's say m equals to minus 2 will be a little towards the y-axis. So maybe you can say m equals to minus 2 will be a little bit towards the y-axis. Okay, towards the vertical. Okay, I just gave you the idea of slopes. This is what slopes are. Okay, but again it is very important that you should understand the literal meaning of a slope. I am pretty sure that you guys already know what the literal meaning of slope is, but then still I'll remind you. You guys may have understood slope by the gradient idea, which is the change in x by change in y by change in x. In other words, what we look is, as x is increasing, either y is increasing or decreasing. If with the increasing x my y decreases, then invariably the slope is going to be negative. If with increasing x y also increases, then the slope of that function will be increasing. Okay, but if you go a little textbookish, you will again find y2 minus y1, x2 minus x1. And what is this y2 y1 x2 x1? So a point x1 y1 and another point b x2 y2, this is what the slope for these 2 points will be. Okay, x2 y2. I hope that is visible. Yeah, so the slope between a and b can be calculated with this formula. I hope that is clear. Let me erase everything and write the slopes down. So this is m equals to -5, this is m equals to 3, and this is m equals to 7. We have still not calculated for this one. Simple, let's do this orally again. So the point towards the LHS of the critical point 1 is all of the modulus values will be negative. So this is 4x, this is 2x, that is 6x. But understand, for this critical point 1, the slope will be -1. So this is going to be 4 plus 2 minus 1, that is m equals to 5. I'll tell you why I'm jotting down the values of the slopes for a very simple reason, because this will help me to draw the predict the shape of the graph. Okay, you may have seen in your some explanatory videos how they are certainly able to draw a graph like whatever, like this, or a boat shape like this. Okay, I will explain you how we do this thing. So pay attention. First thing first, you have to give me at least one coordinate. How can I be sure of that? So let's say I am substituting for x equals to 5 and I want to know what is the y coordinate. So I would want to know one of the let's say this thing, the coordinate of one of the points, one of the lattice points of this graph. Substituting for x equals to 5, this thing disappears. This becomes 10 minus 5, which is a 5, but there's a negative sign outside. 5 minus 1, that is a 4. This is going to be -1. What is it that we got? We got 5 comma -1. All right, that's it. We don't really need anything else. Now please appreciate, this has a slope of -5, which is going to be steeper, something like this. But I mean, for the time being, let's not make it too much. मतलब बहुत ज़्यादा इसको एकदम real करने की ज़रूरत नहीं है, थोड़ा समझिए इसको, ठीक है? The next is a increasing slope of m equals to 3. How can we draw a slope of m equals to 3? Let me draw it like this. Then the other one is m equals to 7, so I can possibly draw it like this. And the other one is, so maybe, hold on, just a second, let me draw the lines a little too elegantly. So how I can draw them? So suppose the first one is a negative slope, so instead of like this, I can draw it like this. Second one could be like this, the third one could be like this, and the last one could be like this. Again, this is a visual idea. Okay, now if I ask you, tell me what is the coordinate point of this? ठीक है, यहाँ पे पता नहीं क्यों लोगों का ना पसीना छूटने लगता है कि यार how do we know the coordinate point? Please do not fret. You know that m equals to y2 minus y1 upon x2 minus x1. See how many variables you know. You know that m is equals to 3. You know the value of the slope. Do I know anything about this point? Yeah, I know the x coordinate is 2.5. So this is already 2.5. I need to know the y coordinate. How can I calculate that? So either you can substitute that into the equation and you can predict, or I would recommend use this formula itself. So this is 2.5 minus 2.5 minus 5. So let's write it like this. You can do it mentally also. It's just that I'm doing it like this. Y2 I don't know, but y1 I know. Y2, keep it like that. And y2 minus of -1 is +1. That is equals to, slope is 3, mind you. So this is y2 plus 1 equals to 3 into minus 2.5. I hope you can see that. This is 3 5 are 15, 3 6 1 7, 7.5, negative 7.5 minus 1, that is equals to y2. Or y2 comes out to be minus 8.5. Now can you tell me, can you see how easily we were able to find out this value? Minus 8.5. Now my dear friends, at this point I would ask you a very, 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 very important question, that why did we do all this business to solve the equation, right? And the equation is equals to -3. If you are not able to understand, I will just say that don't try and figure out too many things. यार हमने कहाँ से शुरू किया था, हम कहाँ पहुँच गए? Just try and think of it as like this is equals to y. Y is also equals to -3. Just tell me what line is y equals to -3. Okay, y equals to -3. Let me choose a different color. Let's say, so y equals to -3 will be somewhere over there. Okay, या फिर थोड़ा सा अगर इसको और ऊपर ही बना देते हैं, somewhere over there. Okay, all right. I'll explain exactly what I'm doing. Okay, but just give me 1 second just to, so this point is 2.5 comma minus 8.5. Okay, this point is important. And this is a line of y equals to -3. This is a line of y equals to -3. Where the graph cuts the line y equals to -3, I hope you would appreciate that is the value of those, or the solution of that set. Effectively, y coordinate हमें पता है. We just need to find out the x coordinate. We also know that the slope is m equals to 3, and for this one, it is m equals to -5. We will again use the same logic, which is y2 minus y1 upon x2 minus x1, that is equals to m. ये रामबाण है आपके लिए, ठीक है? I don't like to use such terms, but again, so this is very easy now. How do we calculate it? Let's do the calculation bit now. Let's do this very casually. What are the things that we know? We know that this point has a y coordinate -3. So I would just simply start -3 plus 1. Okay, I'm looking at this point. Okay, which point? This point. Plus 1. And then I don't know the x value. Either you keep it x2 or keep it x also. So x minus the other one is 5. That is equals to, the slope is 3. This implies that, let's try to do this a little mentally. So this is going to be 3 minus, that is -2. This is -2, and this thing can be written as 3x minus 15. 3x minus 15. Okay. This 15 minus 2 is 13. This is 13, that is equals to 3x, or x comes out to be 13 by 3. Now I totally understand that this value is a fractional value, and that really does not matter because we just want the coordinate. We just want the value of x. So this point has a x coordinate 13 by 3. And the y coordinate is -3. You can be very much aware that this is -3. We just need to find out the x coordinate. How will we calculate that? Let's do that. Okay, let's try to do that. The same thing. Okay, for I don't know what the value of x is, so I'll keep it at it, x minus 5. Okay, x minus 5 in the denominator. In the numerator, it is going to be minus 3 plus 1, that is again minus 2. That is equals to minus 5. This is the idea. Okay, let's do this a little mentally. So this will yield us minus 5x. You can do this mentally, but I'm using the pen. Minus 5x plus 25, that is equals to minus 2. If you realize this is minus 5x is equals to minus 27, x is equals to 27 by 5. That's it. This value is 27 by 5. In other words, what is the value? What is the value? So the value of x is equals to 13 by 3 is one solution, and x is equals to 27 by 5 is the other solution. Okay, this was how you could have solved this question. This is a very interesting question. The method through which we solved is graphical. It takes time. It took me 16 minutes. Okay, can you reduce the time? Significantly, you can reduce the time. Obviously, you will not be explaining anybody when you will be solving questions, but because I'm explaining, so it took some amount of time. But then when you actually start solving these type of questions, you can significantly reduce the time, so much so that you will be able to reduce it to, let's say, 3 minutes, maybe 3 to 4 minutes. But then again, this is a round 2 type of a question. This is a difficult question. I told you in the very beginning. So that's it. Thank you.